and also kind of some aspect of would like, I mean, in Q&A also we can discuss how kind of I mean students can look into future and like where how they can prepare themselves for what's coming up in this space specifically, and what are the different kind of roles that's going to come up. So that's the outline of today's session that I'm going to cover. Uh, if there's anything kind of before that, I can start sharing my screen. If there's anything that needs to be kind of clarified or discussed, we can discuss it now. Otherwise, I can start sharing my screen. Okay.
Yes, sir. Okay. It's fine. You can start sharing of your screen.
Okay. Great. Okay. Let me know. You're able to see my screen now?
Yes, sir. Yes, sir.
Okay. Okay, this is about blockchain and AI, how it's shaping the future of technology. So I'll start with what is the basic concept of blockchain and why like it came into picture. Uh, so basically, the two biggest I would say innovation or the features of blockchain is one is it's a decentralized ledger, and other one is cryptographic security. It brings in cryptographic security. So decentralized ledger, so you can imagine like it's just another database. So it can store data, you can write it to it, like it is basically storage of information. But the best part about it is, so there are two important aspects. One is it's immutable. Like once the data is written to it, it's very difficult to. I mean, it's almost impossible to change it. So it's really kind of from that point of view, it's immutable. And then another thing is it's a decentralized, so there is no one central authority which can control it. So that's the best aspect of it. So we have seen in the world how central authority, like few people controlling everything, can change the entire kind of innovation. And I mean, it's good sometimes, but a lot of time having control with a very limited kind of number of people or resources, it can kind of stop the innovation. So and it can create a lot of problem, like single point of failures basically. So this is the so blockchain came with this new tech where it's distributed. So there are multiple nodes where you can kind of, which is keeping a copy of the entire information in the blockchain. So if even if few nodes gets down or some outage happen, there are other nodes which has got all the information. So that's why it's distributed and it's immutable, you can't change it. And then the other important feature it has is cryptographic security. So there are so data security is a big problem all around the world. So the innovation came with the cryptographic algorithms, where like it brings the so we have like SHA-256 algorithm. These are really hard to break kind of algorithms, which are like part of the native blockchains systems that are being built. So that's these are the two big advantages, but obviously there are more, like it can prevent fraud, then increase efficiency. All the other features are kind of important, but cryptographic security and decentralized ledger are the two important aspect of blockchain architecture. Because of that, it's getting popular, and I'll kind of discuss how it is being used in different industries today. What aspects of it is kind of being useful, and I'll cover some applications also. I'll show some applications in different areas. So moving on to the next one is the current use cases of blockchain. So first of all is it's cryptocurrencies. So Bitcoin and Ethereum are one of the kind of biggest cryptocurrencies out there. So they are built on blockchain. And Bitcoin, I mean, it's getting very popular. Kind of a lot of negative news also around Bitcoin when it started. I think a lot of anti-money laundering was happening when it started, but a lot of that is going away now, and a lot of countries are adopting it. So I'm not sure if some of you might know, but Bitcoin is one of the legal tender, like the main currency of country called El Salvador. So you can buy anything with Bitcoin in that country. And a lot of, like, even with US this week, Trump came into power, and he's a big supporter of Bitcoin and cryptocurrencies and blockchain. Um, yeah, and not just that. So cryptocurrency. So even India. So they are trying to, because blockchain is such a great tech. They are trying to build the central digital currency, like even rupees as an INR as a currency. So they want to get rid of the physical notes now. So for that, they want to replace it with digital version, which is called CBDC, Central Bank Digital Currency. So right now there are almost 70 countries which are trying to bring currencies to blockchain. Yeah. So sorry, somebody was saying. Okay, moving on to the next use case, which is ed tech. So, I mean, this is something might be useful for the college also, or maybe I'm not sure. I mean, if possible, if somebody could run a POC, that'll be great. So, University of Nicosia basically it issues academic certificates on the blockchain. So, anybody, like, you can just pass on your kind of information, like where exactly which, like, there are blockchain kind of transaction hash which you can give it to your employer or other institution where you're going, and you can verify your qualification instantly. So basically imagine yourself like, once you pass out from this college, you are going to you're going to the university in US, and you want all your kind of documents like degree certificate and everything. Imagine they are already on the blockchain, which is secure, and it's always there, like always available. So you just need a hash of that, and you can share it with anybody. So it can be like, it can make it so easy, some of these processes and some of this with the blockchain. And it's already been happening. So as shown here, our University of Nicosia is already doing this. So this is, they issuing academic certificates on the blockchain now. And then the other areas are healthcare records, like, uh, this is an interesting one, because imagine we going to the doctor, we like, or store your personal information. So this is another area. There is a company called Medical Chain which is using blockchain technology or to secure basically to securely manage health record for patients. So like, you can, like, every patient will have their own encrypted data, and that can be used for anything. I mean, doctors across the world can access that data once you, obviously once you kind of allow them to kind of have your data. They can have access it, they can kind of get pattern of like what's been happening. So there is a bigger overview of your information would be there, and the treatment process would be better. So this is already happening in Medical Chain is a company which is already doing it in US. The other area is supply chain management. This is again, I mean, because there's so many. Whenever, like, if you have to send a parcel from here to say US, there's so many different supply chains it will go through. So imagine your FedEx is taking, then somebody is coordinating with somebody else. Then it's being, if it's a big parcel, it has to go through shipping containers. So imagine, like, there was no one single system where securely you could track it. But now with blockchain, it's already happening. So the companies like Musk is a big shipping company, and then FedEx, they are using blockchain to track the entire, like, shipments. So they know where exactly the kind of shipments are, and they're able to track it like securely in one system. So these are the use cases which are already being happening right now. So there are innovation in other areas also. There are so many other areas where it's being kind of used, but these are like notable ones where it's being used. So I'll cover these applications here today, because I'm personally involved. Last 4 or 5 years, I've been involved in like testing and quality assurance of these products. So I'm more closer to these ones. So first, I'll go with the decentralized finance. So what is basically decentralized finance? So right now, if you have to take a loan or you have to transfer money, you have to go to a bank or like one central place. So these banks have their like, because everything is centrally controlled, so there is a lot of like issues there. Like if you have to go to you have to take a loan, right? So you have to fill all the forms, and then you have to share all your information, your salary slips, and so many things, right? So but with decentralized finance, these things are getting very easy. So then these are smart contracts, where contracts like they are programmable contracts, which basically will check. So you can like for example, I'll show you a lending application where you can take a loan from a decentralized application. But obviously you need to pledge something, you need to put an asset which you have as a collateral, and then you can borrow from that application. So I'll quickly show you this. So, for example, this platform called AV and Compound. So these ones are, imagine, like this is the 1 billion is the borrowing amount from this platform currently is being borrowed, and this is the 2.7 billion is the collateral that is being placed. So basically, you, for example, you have any kind of tokenized asset. For now, the tokenized assets are mostly cryptocurrency like Bitcoin or Ethereum. So, for example, you have Bitcoin. So instead of selling your, if you need money, instead of selling your Bitcoin, you put your Bitcoin in this platform, and you can borrow your money, and you can then return the money, and you can get your Bitcoin back. So this is for Bitcoin now. But imagine in the future, where a lot of your assets can be easily tokenized. For example, if you have a watch, or if you have something valuable at home, even maybe your kind of a small parcel of land somewhere, or your flat apartment, if it could be tokenized, you can just pledge it here in this system, and you can take a loan. And once you return the loan, you can then have the control of your asset back. So that's why a real world asset tokenization is a big area that's coming up. And you can already see, I mean, it's already being used. So AV, if you see, the total market size in this platform is 28.57 billion. And this is not, there is no central entity in this platform. Imagine, everything is happening programmatically. There's nobody who's lending it directly to you, there's no other person on the other side, and it's just all happening with a smart contract. And it's like you can see the total borrow is around 11.9 billion has been borrowed from this platform. So that's the scale of these decentralized applications from using blockchain, which are already being used by a lot of people, and they are participating because they understand it's secured by blockchain. So these are, I mean, there are a lot of risks also, but you need to know which platforms are kind of good enough and which are more secure. So this is like, for example, lending and borrowing. So this is one example of lending and borrowing. And if we the other one is decentralized storage. So I'll go to the next one, which is, so, for example, if you have to store any information, I mean, obviously, as personal use, we don't need, I mean, a lot of storage. So, on our mobile, on our laptops, it's big enough storage. But imagine the organization, they are spending so much on AWS clouds and so many other kind of cloud platforms. And cloud platforms are like notoriously kind of known for having very expensive over the period of time, as your storage space kind of increases. So a decentralized storage is basically imagining that if I have a computer which is, I'm using, say, only half of kind of storage. And then a lot of other companies where they have data centers, and half of their data center is not being utilized. So imagine they can rent out their storage to somebody else. And I also can rent out, and I can earn money on the spare storage that I have today. So there are a lot of platforms which are enabling that, So this is a platform called SIA. So basically, this is a client where you can just directly connect with it, and you can just even like you can rent out, like you can take a space and store your data on there, and even you can host also. So you'll get money also if you provide your storage. So this is connecting decentralized aspect of blockchain. People are like in places in different like in different places of the world, basically storing this data. Like for example, this 50 terabyte of data is stored kind of in this place, and this is a and this live tracking of like where it's being stored. All the information is all on the blockchain. So these type of systems are also coming up. Not just this, not just data storage, even for example website hosting platforms. So imagine you have a very critical website, I mean maybe Amazon, or imagine kind of those websites are there right now. So they are hosted on centralized systems. So if obviously they have data backups, but if they went off, say for example is on the Republic Day sale, Flipkart just goes off, right? So imagine the impact on the business they will have. So there are like no lot of blockchain platforms they are coming up, which are providing decentralized hosting services. So basically, your website is not hosted like one or two or three backup servers. It is hosted across the world on decentralized servers. So there will be hardly any chances of ever kind of going it down. So that's the kind of scalability, that's the kind of security you get with the decentralized systems. So this is another area which is kind of data storage is equally important. And then non-fungible tokens, I think NFTs were quite popular, had started getting popular in the last few years. So basically, NFT is again, it's just a digital asset of any artwork, any collectibles you want to have. So that will represent that you are the owner of that particular item. So right in the music industry recently, so they are getting very popular. So for example, uh, the artists are creating kind of they're tokenizing their songs into NFT, and then they are instead of like and they are sending or transacting these NFTs on blockchain. So one of the guy in America, and there's an American DJ who's believed to have kind of earned almost 11 million by selling these NFTs. So basically, this is a nice kind of a way of tokenizing your asset. So this is another area which is coming up where a lot of your artwork, especially for great for artists. I mean, artists now. I mean, for many years they have not been able to monetize what they have been doing. So with this kind of technology, they will be able to monetize their work, and they'll be able to trade it with people around the world sitting just right in their wherever they're based. So that's another kind of use case which is getting popular. And the last one that I want to cover here is decentralized autonomous organizations. So they're called DAOs also. So DAOs are getting popular because imagine it's a automated government. So basically, every decision that's being taken is all programmed. So if you imagine from like for example daily government or something which is running autonomously without any kind of there's no people kind of like corrupt politicians out there in any of the places who's kind of all the funds are being kind of channeled properly. So this is getting very popular in blockchain space because you can use smart contracts to put the rules, and then you have voting system also. Like it's just not like only in the smart contract. So you can like you can build a government, and you can ask democratically, you can ask people to vote if there is anything, and if they don't vote for it, then like you vote negatively for that, then that doesn't get implemented. So for example, this is system called decentralized decentraland. So they have like system like this. So you can submit a proposal on this one, and then based on that, like for example, you can submit a proposal here. What do you want to do? And then the remaining people can come here and vote. Sorry, it didn't work. Okay, I think it's not working. But yeah, I mean, so that's the idea of it. So you can submit a proposal if you want to make a change to the system. and if everybody agrees, they need to have stake in that system. For example, if we want to change, and imagine that in the college itself, like if we have a DAO in the college, and if we want to make any changes in the propose any changes in the college, and if it is got like, and based on number of, like, you can issue a token, and whoever has the token has the right to vote. And then based on like number of votes and kind of what number of tokens you have, you can have different proportion of your voting power. And it is all defined by kind of algorithms. And then kind of people can come there and vote based on what changes they want or they don't want. So all that is driven kind of automatically. So that's been already started happening, and it's going to get more widespread in future. So that is kind of, these are main four areas that I have worked personally in the last 4 to 5 years, which are like getting shape. But obviously there's still a lot to work in these areas, and they're going to get better over next few years. Okay. We'll go to the next future use cases of blockchain. So, as I said, RWA, which is real world assets tokenization. So, it's believed to be $10 trillion industry. I mean, so this is going to be massive. So, I am currently in talk with a UK based company. There's a consulting kind of project coming up there. So they are also getting into this because they have realized it's coming up too fast. So what they are trying to do is, so they are trying to reach out to the big players like JP Morgan or the previous traditional investment banks, and they have their own assets. And then there are assets on decentralized side, which I had shown you earlier, like of compound, where like billions of liquidity is there. So they are trying to build an infrastructure where they can tokenize uh, assets of investment banks, and those assets can be traded on decentralized system, or decentralized systems can be traded on investment banks. So that work is already in progress. So this is going to go really really big in coming few years. So real world assets tokenization is a big area which is focus of like in blockchain. It's a big focus out there. Internet of Things is another one. So IoT is being getting popular, especially with electronics and kind of telecom folk out there. I mean, they are into it a lot because that's where it's being a lot of its kind of features are used. So IoT is basically smart devices that's being built. The biggest challenge that they have faced in last, I think, few years is it was easy to hack any IoT device, any smart device. So there were like, it was quite hackable. But with blockchain coming into the picture, data whatever being kind of sent on or recorded from IoT is getting immutable. It will be difficult to change. So it'll be very difficult to hack. So that will be another big area where blockchain, AI, and IoT will come together, and it'll make our like lives easier. So you can just kind of imagine having smart devices all around industries, all around kind of the cities. So smart cities are kind of being built. So traffic lights, for example, will get more smarter. They can kind of uh, gather the information around what is the how much is the traffic, and based on that, dynamically it can change, and that data is secure also using blockchain. So that's another area which is getting kind of going to be more kind of developed in using blockchain. And then I was the public sector and government transparent voting systems. So this is another area. I mean, I was looking at one of the use case on Indian government website where they are trying out a POC with a remote voting system. So basically, imagine there are like armed forces which are posted in like Sikkim. They are not based in their kind of home constituency when the voting happen. They are based somewhere remotely, like someone is posted in Sikkim, Jammu Kashmir, and they want to vote. So so using blockchain, there's a trial project or pilot project is happening where they're trying to capture these votes, encrypt them, and they get decrypted only on the day of the voting. and then the vote is counted. So that pilot project is already in play. So I think in few years, or maybe a couple of, like maybe by next election, you might know. Uh, so those people also, or if I am sitting here and I want to kind of in Delhi, I want to vote, I can do it remotely from here using blockchain. I think that is another big area that's coming up. So in future, you would see that flexibility in voting will get better with blockchain. So these are main use cases that I see that's going to come in the blockchain space. Okay, go to the next one. The role of AI in blockchain innovation. Yeah, I mean, as I was saying, AI is everywhere in blockchain, because imagine AI, like artificial intelligence is all based on data. I mean, but the problem with data right now is in a lot of places the data is not trustworthy. So that's where the blockchain is going to play a big part, because blockchain brings transparency and integrity in the data. Like your data will be more, like it will be secured, validated data, verified data. Only then it goes, it goes to blockchain only when it's validated and verified. So imagine AI, like your every algorithm. Imagine, like whenever you go to ChatGPT and kind of ask any question, it'll always say that ChatGPT can be wrong because the source of data is not verified and validated. But going in future, all of that data will be validated by blockchain, and AI will be using that data to gather information from it. So it'll be amazing kind of partnership with blockchain. I mean, it's a big role. AI and blockchain together will follow. So in terms of, like, there can be enhanced, because if there is any it can detect before the transaction goes to kind of blockchain, it can be detected. Any fraud transaction can be detected by AI, or kind of if the transactions on particular blockchain is slow, AI can help optimizing, finding where exactly the problem is, because sometimes smart contracts are because they are just like code, or developed by developers. So it could be, it can have bugs, they can be insecure. So those inefficiencies can be easily detected by AI. So those areas it can quickly kind of come in and improve it. And obviously once the data is there, it can analyze data and kind of generate valuable insights. You can take quick informing investment decisions, and the kind of you can see the trends, what trends are there for trading and for different purposes. So yeah, so if you see what are the different use cases with AI powered blockchain, how it would look like. So like one is trading bots with predictive analytics. So AI, I mean, right now a lot of people are doing like share market. They trade in share markets. So they do get information. There are a lot of websites these days which gives you information on their like you can go in a particular company's kind of monthly earning or like quarterly earnings, and you can start reading about that information. But imagine all of that in analysis of all the information for your companies, all done by trading bots. So they will analyze it, they will predict what can happen next, and you just need to kind of, you don't even need to trade. Like all that information is out there, and it's already started happening in on the cryptocurrency side. So there are, for example, this bot here. Uh, so it can help you with the swaps. It can kind of, if you want to do a lending, borrowing, portfolio management, all of it can be done by this AI agent. And then there's another one, this is called uh, Hive. So if you go here, so it's a modular network of interoperable decentralized finance agents. So these are agents which are gathering information, they are doing risk analysis, and then they are able to trade for you. They are doing sentiment analysis on Twitter and Telegrams. All of this info, like there are multiple agents working for you, and then you kind of you're able to trade. So you can just go here. So you can ask, okay, what are the trending tokens here? So it'll give, okay, these are the tokens which are trending right now. Okay, I want to trade this token now. So okay, let me go to this token and want to trade. It'll do it for you. So there's a lot of complexity involved with blockchain. with trading and a lot of systems. But with all the AI that's coming up, all that complexity will be hidden behind the scene, and you can naturally, with your natural language, just like you chat with chat gpt, it'll all be kind of done from, okay, which is the best token to trade now, give me the information, okay, can I place an order from here and manage my portfolio. If it goes up, then take the profit. If it goes down, just sell it at 20%. I don't want to take more loss. So you can define all of that. You can like literally chat with a trader, and which is an automated trader, and you can do it. And it's already started happening in blockchain cryptocurrency space. So that's kind of another area which is getting really interesting, with a lot of bots being developed, and lot with AI, and the AI is helping. So AI is a lot of bots that I've seen recently, which can do technical analysis. I mean, if you see on shares and kind of you would need a technical analysis, you a relative strength index, and a lot of other areas. A lot of technical indicators are there, so you can't do manually. I mean, all of those. So there's like a lot of bots which can do it for you. So they can check every different technical indicators, and based on collective information, if it suggests that this share is a buy or a sell, based on that you can take your decisions. So though that predictive analytics is already started getting built into trading bots. So this is happening on the crypto block, because blockchain is easy to build all of this system, because in the entire data, every trade, every transaction is out there on blockchain, so anybody can see the transaction. They can't see the security, I mean the who traded it, I mean, because it's all wallets, but they can see the transaction value. So all of that can be easily analyzed by AI, and then based on its performance, prices, volume, it can take its decision. So that's one thing that's happening. Other thing is autonomous economies and machine to machine interactions. So this is again, as I was saying, IoT devices with blockchain. I mean, they're getting smarter. So for example, imagine there will be self-driving cars which are doing, like, they are paying tolls, or like kind of they are passing through different places. Every all the systems have IoT, which are smart devices which are able to track it, and it can interact itself with blockchain. I mean, you don't. There's no human interaction in any of that. So all of that can be easily sold by using AI and kind of blockchain. And then preventative healthcare is another area, as I was mentioning earlier. If we have data of a patient for like last 20 years, data is in one single place. AI will be super quick to identify patterns, because that's where its biggest strength lies. So imagine blockchain, which has the very reliable, trusted data sitting on blockchain, which is identified by AI, and AI is doing the predictive, is predicting what could be the diseases. So once AI is trained on reliable data for patients, for healthcare across kind of system, it'll be so easy to identify diseases in future. I think that's one area where I think it's going to benefit humanity a lot, where AI, blockchain coming together and powering the entire healthcare system. So that's another area I'm kind of very excited about, and I see that that's going to happen, and benefit a lot of people out across the world. So that is something I'm looking forward to. So these are main kind of places. So yeah, I mean, this is one example I put for AI, blockchain, IoT. So, for example, I was saying that self-driving capabilities are going to come, and then kind of blockchain will help data sharing between vehicles, infrastructure, everything. And then you have smart healthcare, where, for example, already I think there are a lot of sensors have started coming on your kind of, you can put your arm, you can track your diabetic analysis with the. So if you integrate blockchain and AI, I think all of that can be easily kind of tracked. So blockchain, secure and verified data, AI predicting and gathering, using that data to predict information or the next step, basically. So they will come together. So this is what's going to happen next. And yeah, I mean, so mostly I've covered the basics of like where we are heading in AI and blockchain and AI together. But I was just looking at the number in terms of blockchain and AI space in terms of job prospects, how it's looking like. So global, I've tried to crunch some numbers. So it seems like blockchain technology market is going to grow from like almost 500 billion by 2030, and right now it's almost sitting as 18 billion, or maybe 20-25 billion now, and it's going all the way from here to almost 500 billion. So that's massive. So even blockchain related jobs are going to surge by 300%, and there will be 1 million new open source engineering jobs will be coming up. And AI job market is also growing like that. It's growing at a kind of amazing rate. This is almost 25% year by year, and it's going to be amazing. Kind of, yeah. These two areas and intersection of them will be two major areas that you'll see next like 5 to 10 years. And then obviously engineers and developers with expert in blockchain, AI, cryptography, data analytics, they will be kind of required to solve this problem. So imagine there will be blockchain developers, engineers who are focusing on the software development side of things, and then you have systems and network engineers, which is mostly telecom electronics kind of folks can come into play, because AI, blockchain, all of that needs infrastructure and optimized infrastructure. So there would be ways to kind of use like smaller like how to kind of optimize those hardware also. So, and how to kind of use even the algorithms. How do we change it? So a lot of network engineers and system engineers would be required to enable blockchain and AI engineers to work with. So right now, the biggest challenge for AI is to train data. They need a lot of hardware. So that's why Nvidia, you've kind of heard of it's like struggling to supply GPU. So I have a friend who's recently set up a company which is doing decentralized GPU. So basically, some companies who have GPUs but they're not utilizing it, so they are lying in different places in the world. This my friend's company is building a client which can kind of basically rent these GPUs, and then anybody who's running a machine learning algorithm or training a AI model, they can rent these GPUs instead of going to expensive cloud platforms, and they can use these platforms. So in future, like GPU side of things, hardware side of things also going to be need to be improved. A lot of like networking aspects need to be kind of optimized. So that's where a lot of focus will come there. Yeah, and integrating blockchain, telecom, 5G, 6G networks will be super fast, and IoT devices, as I was mentioning earlier, is going to be big one. I think across the world, you can imagine it was sci-fi movies that used to show like everything is automated in lamps and street lamps and traffic lights and everything on the road you see is going to be all automated. So that will come with AI, IoT, and blockchain kind of working together. I think that will be future where I think a lot of jobs are going to come. And obviously, research and development will be one area which is always been there and it's going to be there. So a lot of like a new consensus how to make blockchains faster, what encryption, and with quantum computing coming to kind of picture these days. So a lot of focus would go in there, like how to improve your encryption or the security of the blockchains, how to kind of make them quantum proof. So those areas will also be highlight for next few years, and kind of contributing to open source projects kind of will where everybody in the world they're helping the open source projects to kind of improve the lives of kind of using tech. So that's another area that's going to come. So those are the main I roles that I see are going to be focused in next few years. So yeah, I mean, in terms of if I have to say, I mean, this is not related to blockchain, but in terms of like obviously some people here might be going out of the college and start finding jobs. I'm definitely sure you would be kind of already using some forms of AI like ChatGPT. But do keep exploring because new products keep coming up. in the market. Because I kind of, when I changed my job a couple of years back, so one thing I noticed was there are a lot of AI systems which are being used not just on your side but on the hiring side also. So if you put a resume and it doesn't have keywords, then your resume will not be even filtered and it will not even reach the employer. So you need to use a lot of these AI tools where you can like embed those keywords that's required for the job. Obviously, I mean, you need similar experience, but those keywords are important so that your resume is not filtered out from the rest of the kind of resumes. And those are called ATS compliant, so application tracking system compliant. So those that's a very important one. So whenever you kind of start, anybody here looking for job or anything, just start using these AI resume builders, which helps you build these keywords. And they, you can then see, you can track, okay, for, you can specify a job profile, you put it there, and then you check against it whether your resume is how much percentage it is compliant. So those things you need to be smart enough to identify, and then also kind of build on that. And then there are a lot of tools that have come up in the market where you can it's like AI based systems where you can kind of practice your interviews with the AI chats. So basically there are literally AI bots which are trained specifically for hiring interviews, and you can have mock interviews with them. You can kind of, they'll ask question, you'll need to specify what kind of role you're looking for. You'll be able to ask them, and they're going to ask you question. It can be technical questions, behavioral questions. So that finding a job landscape is going to change very soon. So you need to come prepared for that also, where you need to practice these mock interviews with AI, and then kind of learning, getting feedback from there, improving from there, and kind of changing and doing it again, over and over again, because the market is going to get very competitive. So you need to have that edge to kind of to be able to go and get the job. So so if the tools are there, so I would suggest, yeah, I mean, there are a lot of them, so you need to just filter out like which suits it like best for you. It could be just simply going ChatGPT and kind of asking, okay, ask me questions, 5 questions, and then getting an answer, and then this is my answer. How do you rate it? Even that kind of is going to be useful. So go prepared whenever like you go in the market, because market is going to get tough. So that is one area that I, other than blockchain and AI, that is AI which is specifically should be used for your next step. And obviously there's a lot of if I look from my, if I have to hire somebody, then I always look for like what kind of projects, passion projects they have built. Like, so your project should be there on GitHub. Ideally, if you can have on the README on the GitHub, if you can write what's the problem you're trying to solve, and then if there is a small website which can even easily create with AI to showcase what you've kind of done, so that'll be great. So if you haven't started like in engineering, I think a lot of that will be required in a lot of jobs, where you should be able to demonstrate using GitHub and your projects what you have built. So I think that is resume, a lot of focus on resume, interview process, and then obviously projects that you've been building. I think those will be two important aspects there. So I'm just wondering, yeah, I mean, that is it. Yeah, I mean, I'll open it for question answers and discussions. Santosh sir, are you?
Yes, sir.
I'm not okay. I can hear you now. Okay, so I think you have covered kind of, yeah, the different topics you have, but remaining time we can kind of, yeah, we can use it for any questions anybody has here or anything. I mean, they expect in the presentation which was not there and not would like to have. Maybe, yeah, we can have a discussion around it. Any Q&A? Yeah.
Actually, sir, how this AI can enhance the security of the blockchain networks? And okay, sir.
Yeah, sure. So if you see how the blockchain network is secured today, so there are
Hmm.
different consensus algorithms that are being used. One is called proof of work, and the other famous one is proof of stake. So proof of work is basically so it's a, for example, you are a participant in the network. You are running a blockchain. You are supplying the hardware, and it is trying to solve a cryptographic puzzle, which has got a secured algorithm. So you'll try to solve that puzzle, and if you are able to do it, then you are able to block. You are able to mint a block which gets added to blockchain, which is, so this is already very difficult. So it's already, that's why blockchain is already very secure. But what happens is sometimes the transactions are can be fraudulent. Like the some people, some kind of entities could try to do the. So there is some concept called front running. So front running is try. So there is a this is called temporary storage before a block is minted. So data transaction are stored in before, just before the blockchain. It's called mempool. So in mempool, the transactions are stored. So some nodes, they can track that transaction. And for example, if there is a lot of transaction about buying a Bitcoin, right, in that sitting in that place, and then one node has got AI on it, which is trying to observe, okay, what kind of transaction are there, and they say, oh, the Bitcoin is, the lot of buy transaction are coming for Bitcoin. That means the Bitcoin price will go up. So before that, let me send my own transaction before these transactions. Yeah. And so that before these transactions go in and price increases, I will already have bought the Bitcoin, right? So those kind of nodes will come into play very soon, because with AI it will be very easy to analyze this information. So that's where, instead of using AI for this kind of work where you're trying to do front running, it's called front running, it's, you need another kind of AI which is able to stop these people or nodes who are doing front running. So they should not be able to do it. So AI to identify these fraudulent transactions or the front running transactions, they need to be a bit smarter to kind of identify, okay, whether it's a front running or not. So it can depend on a lot of like timestamp in the block, like when the actual transaction, the first set of transaction came in the mempool, and when this the new transaction which is trying to front run came. If it came very late, and it's trying, so the way transaction goes in the block is through the fee, the extra fee you are paying. So you're giving a tip to extra fee you are paying, and so that your transaction can be included. So there are ways to identify these kind of transactions, but you would need AI to quickly take that action. So that's where those are the areas where I think AI could be really helpful, because this is something manually is not possible. Only AI can kind of go in there and do that. So this is one area which I think identifying those front running fraud transactions would be a big area to use AI for.
And also in the AI-powered security measures regarding the blockchain, because in the blockchains we are using the wallet for different trade the different cryptocurrencies like Binance or some
Yeah,
another exchange also. So how can we improve the security of that
yeah.
wallet?
Yeah, so that's a really good question, because I have never seen blockchains getting hacked. There are hundreds of blockchains. Blockchains are not hackable. So there are a lot of misconception in a lot of places. Like, okay, the Bitcoin got hacked, or the networks are not hacked, because the way that blockchain is designed,
Hmm.
it's like it's very difficult to kind of tamper the data. So the biggest thing that happened is these wallets that are there. Wallets are just another web 2 system, or they are built on like normal Java and all the other normal technologies which are not used in blockchain. So that's a different technologies being used, and they are trying to use that integration between wallet and blockchain is the place where it gets hacked. That integration part is where most of the kind of places or most of the cases you've seen or you've heard of is hacked actually. So that is one area where AI could be used. So this is so I mean, it's being used. So there are a lot of new wallets coming up. There's a wallet called Rabi. So what it Rabi does is it does a simulation of your transaction before it actually do the transaction. So if in the transaction, it will give you all the information using AI. Like, okay, this is the amount being sent. This is the wallet being sent from here to here, and then you can easily verify and like, okay, this like from the high level, it's looking fine. Like from your side, right? It simplifies because when you transact using wallet, you just click okay, 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 because the actual address of the wallet is so complicated, it will be very difficult for you to understand like whether it's correct wallet or not. So that's where some wallets are using AI to make that simpler. For example, you can store your wallet information with some simple names, and it will ensure during simulation that all that information is kind of secured correctly using wallet security kind of. So it is using AI to do that simulation basically, and it'll be easier for you to, okay, this is simulated transaction. If it is goes through, then the actual transaction will be kind of followed. So lot of like copy paste kind of which tries to kind of hack your wallet. So those transactions are getting identified using AI now. With a lot of wallet companies, new wallet companies, they are kind of using that tech.
Yes, yes, yes.
Yeah, no, that thanks for asking this question. I mean, these are kind of, yeah, really good questions because, yeah, I mean, I mean, this is a new area. A lot of people are not used to it, but kind of it will be important to kind of understand how, and it needs to be safe also. Being secure and safe is equally important in this space.
Yes, yes, yes.
I would love to kind of, yeah, answer any other question anybody has. Anyone from the student fraternity or kind of, yeah, anybody else here wants to ask about anything?
Actually, there is a concept called as a mining.
Yeah.
So what is that concept that we are using in blockchain?
Yeah. So this, I was explaining the same, so that I didn't use the word mining. So basically, when you are solving a cryptographic puzzle in Bitcoin network, so that is called mining. So basically, so for that, for solving that puzzle, you need to try a lot of combinations of input data. So for trying that those number of input, you would need a strong compute power in your kind of whatever system you're using, right? So whatever software you're using. So that's why you'd see a lot of mining centers. These are called mining centers in China and a lot of places where you have like stacks of servers are like stacked together, and they are all trying different inputs to solve this problem. And so if you solve that puzzle, then you get a chance to create a block. Any transaction included in that block, you will get rewarded for like some Bitcoin for mining that block. So that process is called mining. So basically but it's not. Earlier when block Bitcoin was quite new, it was possible with small machines also, even your like laptops. But now it's very difficult. I mean because Bitcoin natively also, when it was designed, it is designed to make it harder to mine Bitcoin. So Bitcoin is 21 million fixed supply. You can't have more than that. And there is only 1.4 million Bitcoin which is still to be mined. Everything else is already mined. So every 4 years there is a process called halving. So after that it will be very difficult to mine. So the puzzles get so complicated that you would need more compute power to solve those puzzles. So that's why you will see a lot of mining centers across America and China where their servers are stacked and a lot of compute power is being used, which is kind of trying to solve these puzzles and try to mine it. And you, as a mine rewards, you would get Bitcoin. So that's how it's happening. So earlier it was using. It's believed that it's using almost a power of almost like the electricity power of almost 5 to 6 countries. That's the amount of Bitcoin mining electricity power is being used. But a lot of countries these days, Like Bhutan is a great example. So Bhutan, surprisingly, I mean, nobody knew this before like 6 months. Bhutan has got one of the most number of bitcoins right now as a government, and what they are doing is they are using a lot of renewable energy to mine bitcoins basically. So they are using because the way Bhutan is situated, so they have got all the different kind of hydropowers and kind of system where they are able to use renewable energy to kind of generate this power to kind of mine bitcoins actually. So they are one of the biggest in governments. They are one of the biggest Bitcoin holders right now. So that's the new pattern that's coming up where because there's a lot of power needed and there's a lot of backlash from community saying it's creating pollution or it's not safe for environment to mine Bitcoin. So that's where most of places it is being kind of moving. They are moving to renewable sources of energy which can be used for mining Bitcoins.
Yes, sir. Yes, sir. And one more question from Javed, sir. What are
Mhm.
the threats of AI in future, especially whenever you are uh, concerned with teaching field?
Yeah, threats are everywhere. And I was talking to my kind of friend, and we were discussing about because there was Facebook said they will replace their engineers, mid engineers, like mid experienced engineers with AI by 2026 next year. So they are saying that they will be capable enough. Uh, I would say, I mean, next few years, I think I would say couple of years, even in teaching you'll be using AI to aid your kind of teaching kind of uh, part would be there where because AI is still not trained enough. You need a lot of time to train models for a pattern of like training, right? So everywhere, I mean, even the curriculums and you need a lot of standards. For example, if everybody is using like USA curriculum across the world, and some models are trained on USA models and it'll be easy to kind of replace teachers with that. But every country has every universities in every colleges have their own kind of way of teaching and way of curriculums also are different across different. So it'll be you won't have the same models teaching everywhere, right? So it'll be difficult to build that kind of models and it's not easy to train that. And teaching, I would say, would come a bit later because that's not a high risk on investment kind of for companies, right? So that's one area where I mean most of the companies are getting into trading and those areas where it's making money because you need to spend a lot of money to train models right now. So because the hardware cost is so much, then kind of training models you need resources. So all of right now you need to put a lot of money in it. So the focus is on areas which is easy to kind of automate or bring on AI infra and where they get more money quickly basically so that they can keep iterating there. I think then it'll move towards more kind of yeah academic side, teaching side. Those areas will come a bit later. But right now I think uh, uh, how we can use AI in teaching is kind of yeah. I mean, with there are a lot of tools out there which you can kind of if you give information to it, it can make your presentation. It can kind of help you putting resources together from different sources. The information which was not there now you can. It's so easy to pull it together, and especially I mean back like during our days, right? The lessons used to be so boring, right? So it was very difficult to kind of focus on because it was not some because imagine some students kind of understand the text side of things, some understand more by visualizing it, some like some people like reading, some people like watching videos, right? So that possibility was not there before in teaching. But with AI coming up you can cater to all the kind of students out there, right? You can have a kind of video created using AI. Like for example, you have a lesson planned for any topic in electronics, or you just feed it to AI. There will be a video which will be created with really good examples, and there will be a kind of text for that, and there could be a real kind of diagrams, examples which AI can help you build. Obviously, it will need validations. AI is still not kind of I would say smart enough or correct enough right now to kind of do it correctly. You need to do the validation, but it can build different things for you, and it can cater to different students. Like if some students like visualizing by video, watching a video, then you can kind of play that also in the class if that's a possibility. So those things can be easily integrated these days, actually, with this with AI. And also with some platforms are coming where submission of kind of work they have done, correction of the work kind of can be done by AI, obviously with supervision from professors and teachers. So these are the tools that can be easily used, and it's going to be that pattern for next few years. Obviously, at some point, everybody is saying everything will be automated. There will be AI teachers, AI professors. So we don't know when that's going to happen. But for now, I think it's a great time to use this tech and make kind of even like our life easier, and even students kind of get more interested in kind of learning also using the AI tech.
One more question.
Mhm.
How this blockchain can improve the efficiency of broad border payments?
Just a sec. Yeah, cross-border payments. Yeah. So
Cross
yes,
border.
yeah. So I have been working with this Indonesian company I'm working with right now. So they are paying me in cryptocurrency now. So cryptocurrency, the payment that happens, it's called stable coins. So stable coins are directly pegged to dollar. So it doesn't change. Like, it is not like Bitcoin. So it doesn't change in value. So it will always be pegged to a dollar. So basically, they are paying me in dollar, but on blockchain. So these are called stable coins. So they literally, it takes like literally like 5 minutes to do a transaction from Indonesia. Not even 5 minutes. I would say like few seconds. They transfer it from there to my wallet. Literally in seconds, it reaches there. So this is cross-border transaction happening in real time. So I've been using it for almost 4 years now. So and for then I converted into INR using exchanges we have in India. But all of that is simplifying the entire trading system. That, I mean, it's a big problem in cross border transaction. Like, I was based in UK, and like almost 13 14 years I was there. And when I used to transfer money from UK to India, to my brother or anybody, it was used to take days. Like initially when I was there, like 10 years back, if you're talking about, it used to charge so much fee, and then it used to take days to kind of appear in the account on the side. All of that is like reduced to literally seconds now using blockchain. So and that's how all the countries are kind of, even before using bitcoins, they have started using stable coins, which are USDT, USDC. So these are the dollar backed coins, are the one which are being used more for all of this. So I mean, El Salvador I was talking about, and all the kind of lot of countries out there, they have already started using. Even one of the kind of, I was talking to one of the company few weeks back, which is the one that I was talking about, where they are building with JP Morgan, they are building an infra. So they are working with a Brazilian bank. So they are majorly working in Brazil. So they are working a Brazilian bank where they want to remove all the dependency of like cross border transaction, like where if you are doing having a somebody is transferring from remitting from US to Brazil, and then it taking days. So it's everything they are converting into blockchain for them. So that all the transactions are almost real time. So that is kind of it's already started happening in the world, and I'm using it for like the last 4 years now.
Another question, that can we use the blockchain in voting system?
Yeah. Voting is another area that I was talking about earlier. So I mean, voting is so again, I mean, blockchain, the main feature that I was saying was it's a distributed, and once the data goes in there, it's not possible to change it. So because it's
Okay.
confirmed by all the nodes out there. So imagine I'm sitting here, I'm one of the node in blockchain. You are sitting in kind of there, and you are one of the node. So there are millions of node out there which are powering this blockchain. So I have created a transaction which says that okay, this is the vote that is recorded, and this is an encrypted vote. Nobody can see it because when the data in the blockchain, it is hashed by the encryption is internal to blockchain. So when I'm sending a vote, it's already encrypted. Nobody can see it. It land on blockchain, and then everybody, like millions of people, stamp it. Okay, the transaction looks valid. It goes on the blockchain. Nobody now can change that. So this is what we need in voting, right? So encrypted so that nobody can see it, and then it is like secure and reaches to where it needs to reach without getting tampered. Nobody can change it. So which is already kind of the two main aspects of blockchain is solving that problem already, not just for voting, for everything else also, but voting is one of the biggest area where it can be used. So that's one thing I was mentioning earlier, that Indian government is already trying this, running a pilot project for this. So they are already trying remote voting for people who are like for armed forces who are posted somewhere else across the world, and they don't need to travel to their hometown to kind of cast the vote. So they can cast the vote directly on the blockchain, and then it will be captured like that. So that is one of the area which is being going to be revolutionized by that. And that's what I see. I mean, next 10 years I would see all the voting that's happening across the world will have like something like that, where we just go there, behind the scene blockchain is used, we cast our vote, and automatically AI is used to just count the record, and everything will be real time. You don't even need a day for like counting the votes. Like now we need to switch on the TV, and oh yeah, 2 days after we get to know the okay, what are the results of the voting, it will be all real time. You just cast it, AI is just reading the blockchain data, and it just automatically is putting it somewhere. Okay, this is the live counting, something like that. So that is definitely happening very fast. I don't think it's going to take much longer. I think next 10 years, maybe kind of way, most of the organization will use blockchain and AI for that.
Yes, 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 sure. Can we use the blockchain in the concept called as a DeFi, that is decentralized finance application?
Yeah, that's the one I was talking about earlier. So the one that I was showing where we can do lending and borrowing. So those are called decentralized finance applications. So DeFi is finance is like anything related to finance, which can be like lending, mostly like anything which bank does, right? So it lends you, or like you can borrow from there, or you can put your money there. You can lend it through the bank. So all of that transactions or between kind of transaction between people, kind of all that is done through either exchanges or banks. So all of that is now getting moved to decentralized finance systems. So that one that I was talking earlier, where so most of that, like if I have to buy a token like uh, Bitcoin or any token, earlier I used to go to exchange, like we have WazirX and other exchanges here, but all of them are centralized systems. They are not decentralized. So there is one company which is trying to control it, and they are owning all the wallets and everything. So it is not safe to. I mean, obviously there are people who obviously don't know about decentralized. That is the first place they go to buy anything. I also went there when initially I started. Uh, so I would go there on the centralized system, and I would buy a Bitcoin there. And I know I have bought the Bitcoin, but that Bitcoin is not sitting with me. It is sitting on the wallet of exchange. If wallet of exchange get hacked, all your Bitcoins will be gone. So that's where decentralized finance applications are coming into play, where they are saying you hold, like if I am buying a Bitcoin, the wallet is with me. I can create my own wallet. Nobody's controlling it. There is no central party to control it. So I am so they are just giving me a platform to buy it from there. So I will connect my wallet to their system. I will send my money to them like USDT or whatever coin, or US dollars or whatever I buy it with. I'll send it to their system, and then I'll get a Bitcoin on my wallet, and it's stored with me. It's my wallet now. So that's why decentralized is, there's no central party to control it. So all the lending, borrowing happening is like everything is with you now. So you are doing it, kind of, and you are managing it. I mean, for some people it's difficult also. That's why they use centralized route, because they get scared, like, how do I manage Bitcoin if I've already bought it in my wallet? How do I make it secure and all? So that those are the other questions that come up. But a lot of people know that centralized systems are more risky systems to have your assets sitting on. So decentralized is where you have the control of your assets. So that's why decentralized finance. And that the one that I was showing you earlier, lending, borrowing. So if I have a Bitcoin sitting there, and I don't want to sell my Bitcoin for next 10 years. Now I know that Bitcoin price will increase in 10 years. I have bought it. I don't want to now sell it. So these decentralized finance system, where the one I was talking, lending, borrowing, so you can take your Bitcoin, go there, lend it there, and you can borrow some money from there. For example, your if your Bitcoin value is $1,000, then if you need $500, you can borrow $500 from that system instead of selling your Bitcoin. So once you've used your like $500, and once you have got it back, then you return it back to their system, and you can take control of your Bitcoin again. So you don't need to sell. So all of these decentralized finance system are basically allow you to do that. So that's how they are kind of built. That's why I was showing you almost $11 billion on ARV is being borrowed right now. So a lot of people who are involved on decentralized finance system are using these systems actively, and this is not controlled by anybody. Anybody can go there. You don't need a Aadhaar card or anything to transact there. It's just nobody's controlling it. Even you are anonymous. You are just a wallet for them. They are wallet for you, or they are a system for you, which is doesn't have a central authority to control. So this is where it's changing. So there will be no central authority across the world. Everything will be autonomous, run by smart contracts, and it's been running for many years now.
Yes, 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 sir. Now, Indian government is coming with digital currency. So,
Yeah.
can this AI blockchain can plays a role in that developing that digital currency?
Yeah, it has to be on blockchain, right? So any digital transactions, they have to be secure, and the best secure way right now. So how do we secure? Like, how do we store our data? The only two ways is like you secure in a cloud, in a database, or a blockchain. And we have already seen that blockchain is more secure than cloud. So there is no doubt about it. It's already proven. So there's no doubt about that. That all these are called CBDC, central bank digital currencies, and all the even China, India, Australia, US, UK, they're all trying to build their own CBDCs, because it'll be so easier for imagine from a country point of view. They are doing exports and imports, right? So for like if they are buying oil from Iran, and now they have to pay them in the cash, or like, so it'll be so difficult for them, right? So once you have CBDC, your own like INR sitting in digital with RBI, then kind of it can easily be converted into like US dollars, USDT or USDC, any other kind of like cross border transactions we were talking about. So right now with INR, I can't convert into USDT. I had to put INR from my bank into exchange, and exchange. Then I have to buy USDT using my INR, and then kind of I'll kind of use. In future, all the countries will have their own digital currencies, and it'll be just direct conversion from like INR, digital INR to their currency basically. So all of that will be cross border and immediate, running on blockchain securely. So that is definitely coming in next, I would say, 5 years, because I think I was showing you earlier that there are 70 countries who are working on this right now to build their own digital currencies. Because anyways,
Actually,
it's getting already a lot of digitalization has already happened with UPI. I mean, hardly you use cash these days, but all of
yes, yes.
but that is mostly used by retail. But between countries, you would need a digital form of your like INR, where you can do a INR to kind of USD conversion. So for that, you would need CBDC.
Yes, yes, yes. And what about the policies that can be led by Indian government uh, towards the
Yeah.
development of this blockchain technology?
Yeah, so right now the regulations are not very clear. I think that is, I would say, very short-sightedness from government right now, because they're ignoring the technology or the kind of innovation that it can bring. They're focusing on the negative aspect of which people are trying to like trade or do gambling with the kind of tokens and all. So they are kind of some people can take kind of unnecessary risk to kind of lose money. So that is possible with trading and all. So I think the government's focus is like, oh yeah, people are trading with Binance and kind of all the other exchanges, and kind of there is a risk of losing money. So that is one aspect of it. But at the same time, we need to understand that blockchain across the world is just not used only for trading cryptocurrency. It is, there are so many other use cases we were discussing earlier. Voting is one, then kind of, yeah, then you have real world tokenization is one, the big one that's coming up. So those are the areas we need to focus on. So I attended a blockchain conference last month. It happened in Bangalore, and a lot of people kind of came across the from the world there. And one of government kind of he's leading the entire regulations around blockchain actually. So he also was invited, and he was sharing this aspect that they have already started considering tokenization aspect of it. So they are trying to slowly kind of build some regulations around it, like which are the potential best use cases where blockchain is can be used right now in the current format. So they are already considering tokenization is one of the, but they need to lay down the entire rules around it, like what assets can be tokenized. Not every asset can be tokenized right now, but in future, even if, like for example, land registries needs to be tokenized, how the process would be, what does that mean, what infrastructure need to be changed from government side also for that. So all of that needs to be all of that is being discussed right now. That's what I understand from that, that there's a lot of progress is happening from government side on that front also. And that's what I've heard from him. But yeah, I mean, I think government is trying, but right now the regulation is not very clear from their side, like what they want to do. But slowly, I think that will evolve as other countries are also kind of. I think every this year, last year in 2024, European Union came up with their own regulations for crypto, and with Trump coming up in power, so next I think 6 months he's also focused on bringing some regulations so that he can kind of how blockchain cryptocurrency can be regulated in the in next few years. So they don't want to miss the opportunity also, because there's a really good tech behind it, and also cryptocurrency bring volume. If people are interested in it, they want to, as long as there is a framework around it which can keep the security of funds for like users. I think it'll get more regulations sorted across the countries soon.
Yes, sir. Yes, sir. From participant side, you can ask a question. Unmute yourself and you can ask question.
I think Professor Sachin has asked how can AI and blockchain be used to improve supply chain management. Yeah. So, sir, yeah, I mean, it's already, I mentioned this, that it's already being used, but obviously more of that needs to come. So, I think tracking using blockchain is, so like, for example, in future everything will be transaction like one, and blockchain identifies everything as transaction. So if I have a parcel which needs to go from here to UK, as soon as I have given like from warehouse to FedEx or whoever has picked it, with the app they can just put a transaction that this is being done from here. So that transaction on the blockchain is now is visible for everyone, because blockchain is transparent. You can see, as long as it's connected to your wallet, you can easily see where it is now. So there won't be and every I think in future every point of like supply chain will have their system kind of talking to blockchain. So every time a parcel is received, then that information is fed to blockchain and it get updated. Information about will get updated. Even now it's happening a lot of, but most of that information is not, like, they're not using one blockchain. Like FedEx might, they might not be using blockchain. Then in some places, if they're using databases, some places they are using cache to kind of store data. So some are using blockchain. So in future, that's going to happen. Like one blockchain will have the entire supply chain talking to one blockchain, and you would transparently can see the entire kind of the flow of everything, like any parcels or even anything. I mean, any movement across the world that's happening. Without revealing private information, you can kind of transact. If obviously everything will be connected to your wallets also, so only you can see it. But the public information which can be shared, I mean, all the other kind of participants can also see through the blockchain. So those, all the transaction will be very seamless. So once they are connected to the blockchain, but right now it will take some time because there is no one single source of system being used. Everybody is using their own system. I think that's the future where everything will be moved to blockchain. Any other question? Would be happy to take it. I mean, it's a interesting concept. I would always kind of, yeah. If anything, yeah, maybe sir can share my email ID and my contact, and if any future kind of session is needed around, if a lot of questions are around anything, would be happy to take it again. Okay, if no more question, then I think we can wrap up. And thanks for giving this opportunity, sir. It's always a kind of, yeah, great pleasure to kind of, yeah. Sometimes we get busy with kind of with company work and all of these things we are doing, but like sessions these like also made me think. Okay, yeah, these are things that I had done in the last 4 or 5 years. These are the areas which are kind of getting improved. These are things that have been changing. So collecting that information together and just sharing it with the kind of others are like you. I also kind of reflected back on my journey also in the last 4 or 5 years. So thanks for kind of giving me that opportunity.
Last but not least, the vote of thank. So thank you for joining Mrs. Seema Sihag first of all, and then thank you to today's resource person, Mr. Pradeep. So on behalf of organizer and participant of this faculty development program on next generation communication, so I would like to express our heartfelt gratitude for taking the time to share your expertise on AI in blockchain technology. Definitely, sir, your insightful presentation and engaging discussions have not only enhanced our understanding of this emerging field, but also inspired us to explore its vast possibilities. Your passion for this subject and willingness to share your knowledge with us are truly commendable. So, we definitely appreciate the efforts you put into the preparing and delivering your talk. So, and also being available with us and also provide the valuable feedback. So, once again, thank you for your contribution to make this FDP a success. Once again, thank you, sir.
Thank you so much, sir. Thank you everyone. Thank you. Okay. Okay, thank you. Bye. I'm just dropping off.
Yes, sir. Yes, sir. Pramod sir, are you there? Pramod sir, are you there?
Yes, can you able to hear me?
Yes, sir. Yes, sir. Yes, sir.
Can you able to see me? I was just John and Prasarak.
Okay, we will start. Just let me introduce you.
Yes, yes.
So, once again, good evening to you and all the participants. On behalf of ATAL FDP organizing team, it's my pleasure to welcome you, sir,
Mhm.
as a esteemed research person for today's online session. So Dr. Pramod K.B.Rangaiah is currently is working as a researcher at Angstorm Laboratories, Uppsala University, Sweden. His area of expertise includes microwaves in medical engineering, radio frequency and microwave circuit design, medical imaging sensors, dielectric characterization, electromagnetic simulation, PCB fabrication, and clinical sensor development. His professional summary includes the researcher with a profound specialization in microwave and medical engineering. So, as a key member of this microwave in medical engineering group at Angstorm Laboratory, Uppsala University, Sweden, he has been at the forefront of pioneering the research projects such as DIAMPS, Sensburn, and AI DARDS. His expertise in the radio frequency field and microwave circuit design field and the dielectric characterization of biological tissues for clinical applications. Dr. Rangaiah, his academic journey includes PhD in electronics engineering from Jain University. He completed his MTech in RF communication and his graduation in electronics and communication. He has laid a solid foundation for his groundbreaking works. His career spanned diverse roles from designing a hybrid MICs to contributing to clinical trials in multidisciplinary projects that bridge the engineering and medical sciences. A prolific author, Dr. Rangaiah has published extensively in prestigious journals such as IEEE, Biomedical Signal Processing, Control and Computers in Biology and Medicine. He has also mentored the graduated student and delivered expert lectures and played a vital role as an associate editor and peer reviewer for several international journals. His professional affiliation includes uh, with IEEE, IET, and IST, reflects his dedication to advancing the field, and as a recipient of Canadian Commonwealth Scholarship and multiple Best Paper Award, Dr. Rangaiah has also recognized for his innovative approach to hybrid MIC design and micro sensor development, blending technical expertise with a passion for impactful healthcare solutions. So we are honored to have him share his expertise and insight with us. With this, I welcome today's research person, Dr. Pramod Rangaiah from the Angstorm Laboratory, Uppsala University, Sweden. Over to you, sir.
Okay, thank you. Thank you for the very brief introduction. It was not brief actually, it was a bit more only. Okay, I would like to share my screen, entire screen. And in between the presentation, like anyone have a doubts at any moment, you're welcome to ask. Okay, so is it visible? Is my screen is visible?
Yes, sir.
Okay,
Screen
okay.
is visible and your voice is also loud and clear.
Okay, okay. Thank you very much. So today we'll be discussing about the interbody communication. So since I think like an audience has got some basic idea about electronics and communication. So similarly, like we do have, I will take into a different word and also slightly I will be steering towards this talk towards an medical application today. So if I'm talking about, like I say, I work for Uppsala University. I'm bit much proud enough to work for this university from past 6.5 years. I'm about to complete 7 years here. So I will brief about just for a minute about the Uppsala University. It's having like a very good ranking across the world ranking with respect to Shenzhen for 63 and QS tour around 112 and times like 86. And it's a very oldest university, one of the oldest in the world, and the first Nordic university. It was founded in 14th century. It is 1477, and we have got plenty students and many students from India also. And we have got several campuses at 12 bigger campuses, and we do have like more than 28,000 masters applications. And we have got students from most of the nations across the world, so more than 163. And we have 9 Nobel Prize from our university. We have 3,200 more than that teachers and researcher. I am also one among that. I am a permanent researcher from Uppsala University, and we do have a lot of PhD students, around like more than like 3,800 PhD students, and we do have like 11,000 scientific peer review according to 2020 statistics. And some of the pictures shows like our campus, and I am in the one of the glass building, this one, and these are our like some very old campuses, like beautiful campuses. It's like 300, 400 years before, but still it's being used as a classroom today also. Okay. And we'll come back to our topic. So interbody communication. What is this actually? So you have been communicating through, like we are using many wireless devices. Wireless devices, like say microwaves, travels in the air as a communication medium we use, okay, for the transmission. But for interbody communication, most of the time, when we look for security and also less losses in the channel, so interbody communication is like a cutting edge communication method that utilize human body as a medium of transmission. So, and we look for security and efficiency. So currently available techniques, only three techniques are available. So, and one of the technique like FAT-IBC is being pioneered and launched by our Angstrom laboratory. So that too in our group. So that we are more proud about that technology. Earlier than like FAT-IBC, here they have found that one like around like 8 to 10 years before. Before that, we had got only two technologies called capacity coupling and galvanic coupling. So we'll discuss about like what is capacity coupling and galvanic coupling, and then I will take my talk towards more with respect to fat interbody communication. So capacity coupling is like is relies in external field and the body capacitance, but galvan gives the electric signal transmitting through the tissue. Okay, and fat IBC is mix of this two, and but in a different way. Okay, we will see like what is the difference and why interbody communication is required, because like when we are looking for low power consumption and energy efficient compared to our traditional wireless, say about like you charge your mobile phone every day, and if you take any of the headset or anything you need to charge, but like some of the, what do you say, some of the devices in future inside the body, say about like a pacemaker like an art or any other artificial devices inside the body, we cannot charge every time. So we can charge with the wireless power transfer, but still it's like again it's bit like complex. So we always look for some low power consumption, and also we always look for security. So it should be like confined in the body and nobody like. We do have like a subtitle for some of our projects called "Don't Hack My Body." So that means like don't hack my body, and like we will not allow to hack our body. So those things, and we look for required to have a compact design and versatile applications. Today we have got wearable devices like smartwatches, fitness tracker, and medical devices, implant and biosensor. And we do have like a virtual and augmented reality system that will come. And the key applications we are looking for a future project inside our group. So it's more with healthcare, fitness, sports, and extra reality ecosystems like virtual reality. So these are some of the key applications. That's why we need to work on this interbody communication. And then I will talk about this to existing technology before we come here and we establish PAT-IVC. So what is that is like you can see a single picture is describing both. So galvanic coupling at the left side. So that uses like human body capacity and the external field to transmit the signal that relays and generates electrode based on the body, and that requires an external reference for the ground plane. And this is very simple and low cost. And this is like for a short range of variable, like only for arm, or like only for a thigh. Like in between two this, you can place electrode and you can use this to, like galvanic coupling, and still you can make it. And it is low security because the signal leakage is more, and it consumes more power. Okay, these are some of the things, and you can see some diagrams. It's very simple to understand that. Okay, so capacity coupling, that is comparably has got more advantages compared to galvanic coupling, but the person has to be with the external ground. That means the floor should be always the ground. That means like if it should work, you need to walk on a metallic surface. Like you have to be like every floor should be converted into a metallic cladding. So that is a bit difficult actually to maintain the infrastructure because yes, in a clinical environment we can make it, or else in some of the controlled environment we can make it, or else for regular purpose it's a bit difficult, like in open air or like say about like an outside this. It's difficult. So how its work is like it takes a ground plane and you will have an electric field which is transmitted directly through the body tissue and which employs electrode inject and receive the signal currently, and it propagates through the conductive property between the muscle and other tissues. Okay, this is more important. And data rates and the power efficiency is also good and requires a skin contact always. Okay, and we require a floor always. That is a floor, metallic floor. That is always. And its bandwidth is moderate and implementation is very difficult. That's as mentioned, like you should have complete external ground all the ways. So these are two major technique was there for interbody communication. This is the only two. So now, um, like capacitive coupling and galvanic coupling and fat ABC. Before coming to the fat ABC, I'll just list out some of the features like signal medium, like it is between like electric field through air and body, and galvanic coupling is like electrical tissue through is current through the tissue. But we do have a fat which is very low loss, like a waveguide. We use the body as a waveguide. I will show like how it's done. And power efficiency is moderate, and galvanic coupling is high, and ours is very high. So, and data security is medium, and galvanic coupling is high, and fat abyss is very high. The signal will be confined inside the body. The signal will not come outside at all. So, and bandwidth is very high, fat abyss, and this store like more moderate. And applications we do have some variable fitnesses device, and here we can have implant and biosensor, but here we can have like XR, AR, VR, variable healthcare, many applications. And the antenna requirements, yes, in capacity coupling is required, and in we don't require in galvanic coupling. But as an antenna, we don't require a fat IBC, but we require many probes which should be matched for the skin. So we'll discuss that in later on. But as far as in a general, antenna requirement is not required. So, and implementation cost, it is low, and ours like galvanic and this thing is moderate. Okay, now I will steer completely my talk towards fat IBC now. So fat IBC, there's a fat intra-body communication. Why I have taken a fat? See, every time in a real world, everybody talk more negative about the fat. For our communication, fat is like we will be looking at something good thing about your fat today. So what is that is, let's leverage like fat. We will use fat tissue as a communication medium. That means if you are looking with your body structure, so externally it will be like a clad, like it is covered with a skin, and below the epidermis or dermis, you will have a fat layer across your body, and below that you will have some muscle, and then like bone, or in some few cases in abdomen region, internal organ, or like adipose fat. So there are many regions, section region. So if you are looking with the top three regions like skin, fat, muscle, like if you are looking with a dietetic medium between these three layers, like fat is having a very low dietetic medium and low losses. So, but skin is having around like at 2.45 gigahertz, is like around 38 to 42 based on a different human. And the muscle is having very high dietetic medium, like around like 50 to 55. So like that, but fat is having very low altitude. So that means like fat is sandwiched between a skin and a muscle, which are in very dietetic medium. So then we thought that when we can use like fat as an like a medium for signal propagation, and so that has become a naturally available waveguide. So our body can be act as a waveguide, and which is allowing very high bandwidth and low power signal, and it will be confined inside the body. then data remain very isolated and it is reduced with the interception risk. And we do have several IEEE standards, and it is also one of the standards for communication now. And we have got many appreciation for this technology, and we are working very much to improve this. And advantages is very superior power efficiency and data security, very high bandwidth, suitable for most of the applications. And challenges like cost of implementation that we have to look for it, and we require a right technique to make it, and which requires and a different body composition we have to look for it. And we consider for generalized body structure, and we are made many several animal trials and also human trials. Most of them are successful, and we have come up with many publications on that. And you can go through it if you find that this technology is a bit useful for you in future. So application across this is like already I mentioned, um, yeah, capacity coupling and Galvin coupling has got a few applications, but like FAT-ABC can be used for many other applications for the interbody communication. So I'll go through a basic simple thing like, so when I talk about like now we will I will talk more on like signal processing and also FAT-ABC using that. So you see the body structure, so you will see like skin is above layer, and you have got muscle and fat. Okay, so we will be having a specialized microwave probes especially made for the FAT-ABC, so that we use for as a interface so that will be on body. We have got many on body antennas, in body antennas for both ISM bands 2.45 gigahertz and 5.8 gigahertz. So that will be on the body, and we will be using some modulator and demodulator, and we use many signals like EEG, ECG, and many other signals, and we have got several projects based on this application. So one is like famous project we called Bk, that means preparing a prosthetic arm based on the signal uh, from the motor cortex of the brain. So like this, we do have many projects based on this. So any kind of those signals that will be made with ADC and modulator, and then it will be sent to the probe, and receiving end is same. We'll receive it and demodulate it, and we'll convert into a digital form, and we'll have this received. This is a basic concept. So we will use human body. There's a naturally available fat across our body beneath the skin, and that will be sandwiched between skin and muscle. There's a fat. That fat, this is and we will have visceral fats also inside. We are not currently using those things. We are using only subcutaneous fat like this. Okay. Yes, and initially I started when I came here, I started with some test beds using STR, and I've done some programming with GNU Companion and other Python coding, and I made some several transmitter and receiving blocks for different modulation schemes. And one of the modulation schemes, like it started with PPSK, QPSK, and some of the QAM 16-bit, 64-bit, so and so, and also GFSK. These are different modulation schemes we have been developed in our laboratory. And we have tested something at transmitter receiver spectrums. After that, we have did many measurements. If you are looking with something a channel characteristics, it is following some of the basic patterns. And if you are having a very good receivers and saber rack receivers, or we are able to find something like different multipath, canceling the multipath and reducing the noise inside this channel, and many processing by looking by with the received spectrum, it was working well. And you can see the bandwidth, it's very great actually. Based on the STR which we are available, it was like multi-mode was there, so it was working very well. And almost 600 700 megahertz is a very huge band. So, and it depends upon the test beds, and also depends upon the STR which you are using. We are using B210. That was very good STR. So that we used to make it with ATAS. So with that, we have gotten this kind of an spectrum. And we have got a very good constellation diagram. You can see like based on like simple with odd decision algorithms, it was very easy to identify what are the bits we are transmitting. And it was like inside the uh, reasonable, what is the reasonable points. You can see the BPSK, QPSK and all like very without decision, we can just bifurcate uh, the points easily. So these are the constellation diagrams which we have seen, and we have got several publications on it. And one of the publication recently published in biomedical transactions. So from IEEE, those are all like a very interesting article. If someone want to look for it, you can look at it. And most of my articles are like open access, so it is available online. So you can just go through those things. And apart from that, when we are making all those things and all, we got some idea like we want to analyze the channel in a very better form, not like something a multipath can happen, or else we will have surface wave communication. So we have taken this one is like one of the, you can see here, phantoms that has been built based on some obvious structure. It is like 3 or 4 years back. It is that composition is exactly similar to my body. So we have prepared I was a bit fat at the time, so it was a dimension of my body, and we have prepared that obese phantom on that time. And then we have got one of the here you can see some of the on-body antenna. So we have made those things and we have kept that for analysis from one part, like front to back and side to side communication. And then we prepared one excellent measuring setup with the box. Actually, we have kept inside the box that was then inside the Anakin chamber, and we have placed a separation wall, but that blocks both surface wave and multipath, so that we have improved. And then you can see the separation wall with isometric view. You can see like something like which is like we prepare based on the geometry of the phantom. We have prepared a separation wall, and you can see that. Due to this, we have avoided the surface wave and multipath that can be seen in this curve. Like you can see, without the wall, we used to have like a very high signal, so it's almost like front to back communication, like 13 dB, and another one is 15 dB variation used to happen based on and with and without wall. So then we come to know like to avoid certain like surface wave and multipath, that is very useful. This was another experiment we started, and this we have come up with an IEEE access article. You can just look at it and later on. Um, and then this was our latest, one of the latest IEEE transaction. Here we proved that our FAT IBC can support up to 92 Mbps channel. So we do have this is like the photograph, which is just as shown by opening. So we do have some separation wall, and we do have something in a box, which is what do you say? Which is like to avoid some external noise. And you can see the simulations when you keep the wall like you can see the intensity and the radiations which have been avoided from transmitter to receiver. So these are some of the simulation and measurement setup which we have prepared. And we have used something the latest computation module, Raspberry Pi 4, which is the latest, and with another motherboard. And then we have insulated that to avoid something like to escape certain signal leakage through the UFL connector or a semi-connector over there. So later on, we have prepared a very good case for all those things in future. So during that experiment period, it was just being cladded with some metallic sheets. And then we have prepared a different testing cases for FAT-ABC. So what we have made is like here you can see 3 cases. So case one is like in body to in body, that is like directly probe from side to side, and then in body to on body, and then a third case goes to on body to on body. So for this one, like microwave separation mode, we have made one nice CAD diagram and we have placed over here. So these are the like phantom model we have used for the latest testing FAT IBC. So, and then when you are looking with the transmission coefficient, only with the transmission coefficient. We do have like S11, S22, and S12, all those things, the values. But I want to like most of the, I'm reducing all the content and just placing very few important things in this presentation. So transmission coefficient, you can see we have made that experiment setup, this one. Wait. So for this one, you can, for phantom, we have wait for 10 centimeter, 20 and 30, we have tested for these three cases. So for all three have been like 10, 20, 30 of case one, you can see the implant to implant, it was like working too good and it's having equal separations. And you can see the clear drop in the S21, the lengthwise. It's more like a linear. And when you come for like another, this one here, second one, it's on body to on body. You can see a slight variation and it's very well matched for the 2.45 gigahertz. And only about that, there's expressions are different. And if you are looking, it's not linearly varying. Based on that, we have developed many machine learning algorithms, and it has been communicated with a good journal. When it's published, I can share. Um, and S21 transmission coefficients of in-body to on-body is the last year, this picture. So this one, it is also like if you're looking like from 10 to 20, 20 to 30, it's dropped a lot. So these are some of the basic idea we got from the transmission coefficient values. And then we'll look for some of the bit rate analysis. So bit rate analysis, if you are looking with the modulation schemes from the IEEE standards, so this is like IEEE standard 802.11n, and we are following every time IEEE standards, and we are following same what is it, measuring setup. And idea is to come up with a new standards for fat IBC in future. So still we are working with many other applications, and we are, once it succeeded, then you can see a separate standard for fat IBC. So when you are looking for this kind of an IEEE 802 dot 11n, there is the latest and very highest can possible for the bitrate analysis. So for with 800 nanosecond guard band interval. So for modulation schemes, we are available from 0 to 7. We have tested all the things. Okay. And modulation schemes from BPSK to 64-bit QAM with this standard. Above the standards also, we have made some measurement that I will take it later. And the maximum available for HT20 is like 65 Mbps, and like with HT40 with the 64-bit QAM for complete coding 5 cross 6. So that will be 135 Mbps. You can look at it in this curve for all three cases. We have able to achieve almost like 90% of the like a data rate up to HT20. And when you are looking with the modulation scheme above 5, so for like a 64-bit QAM, so like 3 by 4 and 5 by 6 coding sequence. For that, it has got dropped. Okay, we need to find what is the reason, and but like it's like still it has reached up to 92 Mbps. That means the channel inside the fat, it can go up to that with this kind of unlimited resources. So this was the things we got published, and we have made several other measurements, like with very big equipments from the R&S, and we have chosen which is the latestly available or maximally available QAM technique. Say about like we have tested up to 512 QAM. So if you are looking with the current technology like 6G, 7G, that can still not reach up to 128 QAM. But if you are, we already tested up to 512 QAM, because this technology can long last for more and more like generations, like say about 10G or 20G, whatever. Still, this should support. By keeping that in a mind, we are been measuring that. So very first case, what do you say, left side bottom. So this one is a very like in body to in body. So that has worked very well for 512 QAM, no doubt. And second case, like in body to on body, that has like except a last few for the 512 QAM, it has worked very well for 256 QAM, and like even up to 512 QAM. And the last case, since like on body to on body is very challenging. So that you can see like 16 QAM and like 32 QAM, it's slightly lower. So slightly like bit rate has been made. So it used to work like in this fashion. So in this way, so we would like to tell like we need to be improve and optimize the on-body antenna. That is obviously is continuous work of a research, but we got an idea about like how our fat channels can vary in this way. Okay. And we have compared those kind of an similarity in body communication with the different methods. And our work at the 30 centimeters, like 92 millimeters, is off the shelf. And we have used the modulation scheme just IEEE 802.11n, and it has been tested with on Phantom and the band, like frequency band from 2.4 to 2.45 gigahertz. And bandwidth we have got a 40 megahertz. With the 40 megahertz bandwidth we have achieved that. So if you are looking with the reference 10, 32, and 31, so everyone, or like say about the hardware, the modulation scheme is very much latest and very high modulating, like a 3-level Walsh, and this is bipolar thing, and this DSC. So, and also the hardware they are using like 65 nanometer CMOS, and that is like 180 nanometer CMOS and 65 for like hardware. This is off the shelf. So comparably, this we are winning its technology, and methods are different in their cases, but we win with this case. Okay. So this is a simple comparison for in-body communication. So, and then I would like to talk about like what is our future thinking, because we have been like we have made like a prosthetic arm based on this, and by receiving the signal from the brain, and like we have been like look for many applications. So now, like, what is our like transformation in future? Like, say about VR, virtual reality, etc., data security, low power signals for real-time biometric integrations, and also haptic devices for gaming interface and many other things, and also sports and secure XR user authentication. So these are some of the applications we are targeting. This will be our future FAT-ABC application we are working inside our lab. We have done plenty of that, and it will be too technical if we are going talking on each and every word. So I have made this presentation as simple as possible, and which I can be presented before publishing the article that I have been sharing here. So key features is like secure data transmission. Yes, we have made it. Like we have made many other experiments to see the data security, and low power signal. Yes, yes, it is like the power radiation is like you can say 100 times less than your like mobile Bluetooth signal. And we have tested SR, very less it is. So it's under the limit of European SAR limit. So, and we have got some of the feedback, especially like robotic arms and other things. We do have robotic arms for that haptic feedback. So our current robotic arms which are there, so that is doing certain activities like picking up the bottle and identifying the structure, and placing certain like here that some of the like some simple activities is making for that. So that can be made for the real world, like human computer interaction, and um, many other like intelligent applications, and motion tracking, especially for sports application, and biometric integration that is possible, and user authentication. Obviously, like we do have some properties related to certain humans. Obviously, we can have authentication. Say about I make some customized things for a person that may not work for another person. So that kind of an authentication we can make it. And applications currently like VR gaming, fitness tracking, virtual workplace, and some medical simulations. Actually, this training. These are all our future application we are thinking about it. And we have got some variable applications. Say about like today you have got some smartwatches, AR glasses, and VR suits. These are some of the existing thing. So we can introduce our FAT ABC probes inside that. It is not too expensive, and we can minimize the size, and we can have very much low profile antennas to this fat abc antennas. We can plan for it, and that can be placed. And also diagnosing methods, say AR glass, we are planning in few of the project for glaucoma indications and many other applications actually with eye those things, because like we have been classified with many other like disorders. We can make antennas for the communication, and also as diagnosing certain that like variation inside those layers, so that we can identify few disorders in a human body. So that can be made. And secure data, obviously fat layer, the signal will be confined between those layers, and you will have been enhanced with privacy. And health monitoring, yes, we have been like in few of the project like SenseBurn. In that one, we have been like burn level analysis that we have made it, and for lymphedema, edema patient that we have made it, and bone density analysis. Recently, one of the project we have completed that one, and also we do have another project for comfort that is also we have made. So several projects we have been completed, and we are about to come up with a few more applications on it. And this few of funded by some of the European funded projects we are in currently, and with the excellent science, and we are going for the transition projects. And currently we are going with the TR level 4 to 5, and our objective is to reach for an 5, 6, 7 in this coming years. For coming at least 3, 4 years, we are looking for the high level technical readiness. And also we can look for something military users and some fitness gaming. So we would like to cover. And also apart from that, we do have something smart gym applications and all. So say about like many people are doing exercise, and they may have something like few, like most of them, like after 30 or 40, their muscle gets deteriorated, and they are working in a different manner, but they are not knowing that one what's happening for their muscle. So we are looking for the muscle quality while making the gym activity. So that also we do have some projects based on that. And apart from that, we are looking not only medical applications, we are looking for something else, the structure of the water dams. We are working on something based on similar technology. We are working for the water dams, especially butter structures and embark dams. And also we are looking for the tunnels. If you are looking with here, Sweden and Norway is having more number of tunnels for the health monitoring of tunnels. Now the government is investing a lot of money on it. So we are having some solutions for it. So yes, these are about our interbody communication. So yes, actually, I have finished a bit early the presentation, so that I would like to take more number of questions, so that like immediately I can open certain links in a Google, and I can answer your questions. Thank you. Hello.
Yes, sir. Yes, sir.
Yes, yes.
Participant can ask questions.
Hello, sir.
Yes, yes.
Which simulation tools you would like to suggest for the
Yes,
antenna?
yes. It's a good question. Good question. Simulations too say about like we do have CST and HFSS in our laboratory, and we do have like when you have a simulation, uh, can I take 5 minutes to tell about some simulation things? Is it okay?
Yes, sir. Please.
Yes, yes, sir. Say about like different simulations. Say about like how do you want to simulate the structures? Once you are looking with the 2D simulators, say about simple simulators which are available for EDA tools like AW or MicroOffice ADS. These are simple 2D applications for this. When you are looking with 3D applications, most of them like good library setups are there available from the AWR and HFSS. So these two tools say about require a gigantic RAM location and uh, good machines to make it. So in our university, if you are looking, if the simulation require more time, say about in a local system, it's taking more 45 minutes or 1 hour. So we will run that on AWS. So that makes like supercomputer, that makes the things faster. So I say that whenever you are looking with something like if it is your simulation demands simple intersexual 2D simulation, then you can go for it. And if you want very good environmental 3D structure, see, everything happens in a very simple, like in 3D simulations, it will divide into infinite samples inside the elements, and then it simulates with Maxwell's equations, simple way. And one will make, say, about like CST makes more time domain calculations, and HFS will go with the frequency domain calculations. So, and end result will be same. And most of the time, what happens is during the simulation world, once you emulate or once you fabricate, you will not be getting same result. So because of the fabrication quality and also the how you are going to fabricate. And most of the time, you take the inbuilt models, say about like for a skin or this thing, you will add very few values and ask the computer to assume certain things. In that one, when it comes to the real time, it will not happen. Say about like skin dietary constant, you might have given 38 for few frequency as to interpolate completely and you simulate it. And when you come into the real field, it will work in a different way because my human body and your body, like everybody's like dietary constants varies a bit. And also skin thicknesses vary. Say about starting from your body, say about lower body mass index and like average body mass index. Those peoples are different. Skin thickness is different, fat is different, and then same three-layer human model which you are simulating in HFS or CST does not work at all. So in real time, in a medical application, it happens like that. And when you're looking for the 2D simulation, that is too poor. So when it's more than simulation, you should have your own logic to make it work. And also some of the simulations, say about CST or HFS, is having space limitations. Say about it shows something like you can simulate complete aeroplane there, but it will not do in that way. And simulation files will have huge space, and it demands more time for the simulation. So there are many disadvantages. So that's why you properly think about your basic concept, what you want to simulate. Say about like I want to say about in one of my project is we do have a dam structure. So complete the dam structure I cannot simulate in HFS or CST. So what I do is that I will take a part of it, which is very important. Say about the concrete, the dietary constants and other things and all. Based on that, I start designing. And also say about like in simulation environment, it is not so because in real in Sweden, in a winter, we will have 1 meter snow thickness to 10 centimeter or like more than like 1 meter kind of a thing, snow thickness. So when I start simulating our sensor, which is on the surface of the concrete and looking with the snow thicknesses and temperature variations and pressure variations and uh, you see what you say, humidity level. So these are some of the things you cannot build in a simulations at all. So at that time, like beyond the simulation, you need to think of it. You should make simple calculation, predictions models, and then you have to decide what has to be. So that's how like and also and I want to tell about like many people like when I started my career in the microwave and during 2011-12, and I'm talking about since most of them are academics, so they are more worried about the simulation software. So when I used to do some simulations and I was straight away submitting some paper, it used to get some like accepted. And later on, the competition has increased actually. When 2012-13, like when I was designing a low noise amplifier, I was very few people used to design those kind of software, sorry, components. Now we have plenty. And even at the time, the antenna designers are less number of people, micro people were less. Now there is a huge number of people are working on it. So and also but simulations models inside that, say about harmonic models or like intelligent model, app like models which are being inbuilt. So all those models and all, they're not being upgraded a lot. So most of the academics people, they are working on just a simulation, making some of the things and expecting some of the journal paper, especially when you're looking with very high quality impact factor journal paper. It's very difficult to achieve based on the simulation, and also it's require more time. So that's why, like, if you are being in this field beyond the simulation things, beyond certain things, more with the computational things, you should think, and you should achieve your targets. Also, and look for some better application where people have not been explored much. So the application makes your concepts very stronger. Say about like many people look straight away look for like how many people are working and just for the radar application, because I stare myself, to be honest, like I was working for the some of the project through the third party from DRDO in India. So at that time, I used to work on radar applications. So, and then I was looking for like how many like people are working, and slowly I steered towards the medical application, because like less number of people have been explored and there is lot of problem, real problem. Say about today we are preparing certain sensor that need to be optimized further, and it requires more time to come into market. So there are like when you have larger scope of window to do certain work, then you can survive more. So to be honest, that's why like now the AI and machine learning has come into picture. So even though I'm a micro guy, my latest articles are more with the machine learning and artificial intelligence. Because when you look at like what's next, say about many people stop their work by designing certain antenna or certain things and then they leave it, but it has to be a next level and should be a product. So that's why we are looking with more than like year of 4 to 5, we are reaching for 6, 7. That means we are not only just ending our research to experimental analysis, we are making something better with a machine learning algorithm, and that should be compact for the any of the medical application. So we are looking for the application level. So then you will have larger scope, interdisciplinary work, more publications, and also innovative thing, and you will be having more energy to contribute. And it will be of work for many other engineers also. So, okay, I think you got some idea about the simulations or like,
Yes, sir. And
yes.
one more question. As a beginner, from which tool I need to start, whether HFSS, I3D, or CST, or any other you're suggesting?
So I think I am not against with any of the software. I can give a frank opinion if even though if it is recording the session. Um, I think you can go for CST and HFSS. So CST if you're more with medical application and sensor design, and if you're more with and people in India, many people I've heard, like many people say that HFS is giving more accurate thing. Like what do you mean by accurate? Like both tools work in a similar technology. So something like the proper, if you are defining your models properly in both the tool, it works better. So if you are looking with the commercialization, you're like it's been expensive tool in Europe. So we share our licenses, like one group use by CST and one group by HFS, we share it. So you can look at it the price wise and how your institution can offer it, and if it is a floating license, and if you are looking for 3D simulations only, then HFS and CST are okay. If you are or like a system level, and you have been like need to work for like component level to the system level, so then AWR microoffice from Cadence, that is free for the educationist, so you can use that. So every 6 months you need to renew your license, so that is also very good option for you people if you are looking for something free for the um, education legal version. So there you can have minimum number of 3D simulations that can be made for the CST and HFL. Even that is possible. So minimum concepts. So if you want to define more number of layers and other things and all, these two are the and I3D, it's up to you. If you have license, use it. It's not a problem. But I rank, if I want to rank, I can rank CST first and second HFSS for complete 3D simulations. And if it is a component level, I rank AW or MicroOffice first and ADS Agilent, that is second. Because user friendly is AWR, that's why I'm keeping as the first. And ADS was very good, very good. It's not, I'm not against with that. And above that, we use most of the product from Agilent in our institution. So that comes with like we purchase the product and they give the software. So like that. And by the way, I want to know what is your interest, then I can suggest exactly what you want to buy. Hello.
Okay, thank you, sir.
Okay.
Actually, sir, how do the surface wave
Hmm.
propagate through the human body, and what are the factors that
Hmm.
can affect the propagation characteristics?
Yes, sir. It's a good question. Like, I'll go back to mine. Um, say about surface wave. Say about. Let me. Okay. With just a minute. So, can you look at this? Like,
Yes,
if you
yes.
are okay, not in this diagram, we'll go with virtual diagram. You can see in the first diagram here. So, I would like to annotate it. Right. Um, okay. Can you able to see the spotlight?
Yes, yes, yes.
Okay. Sorry. Okay. Can you see here, like, if I'm keeping like front to back, this is the transmitter and this is the receiver. Okay. These 2 points. And inside the box, if it is there, inside the box is like, this is completely covered with the micros observers, like very good observers. So as soon as the micro falls on it, it should not reflect it back. But practically, it reflects. Okay. In human body, what happens is if you're like you will be in front of this wall or any other objects. So obviously multipath happens when I'm placing the some of the like one antenna on my chest and another one at the backside. Obviously there will be a different path because there are something which is like micro reflectors available. Sorry, all the way it will be there. Say about something like reflector, like not only metal, um, say about some like concrete wall which cannot pass through it. There are more like observers are very less in the free until unless if you are in a very free space. So it will hit those objects and it will come and reach here. So that is multiple. Uh, s- what is the surface wave? Surface wave propagation always happens. Say about like any of the probe, we have been made like exactly match for the skin. Skin is very lossy material actually. It's very difficult for to match because with existing technology. So if it is not matching, then it will scatter the thing. Say about like if you are based on the power, if the power is more, scatters more. That is a simple thing. So whatever is irrespective of the power, it scatters. So, but it grazes the surface of the skin. So when it grazes the surface of the face, just to follow that with some signal and reaching with respect to receiver. So which is like very difficult to avoid. That's why we are keeping a separation wall to avoid those signals. So surface wave means for me it is grazing the signal across the skin and also limitations of our probes, transmission receive probes, because we expect say about like if you're having complete power has to be confined inside the fat, but it will not happen because of the slightly mismatch in the skin. Even though we cannot say by looking at, say, we also make certain experiment. We take ultrasonic measurements of each human volunteer and we find exactly skin thickness, fat, muscle, and all appropriate region. And then we bring that one same thing in our simulation model. We assign the thickness as same. But when you are making a data characterization, with in vivo characterization, we do have some like slim probe, performance probe, high temperature probes in our lab. Apart from that, we have got waveguide adapters techniques for the transmission based dietary characterization. It is difficult because we are not able to dissect the human body, because if we have volume here, we cannot allow them, like we can take only the skin peripheral for up to 1 mm thickness. We can just measure them. So rest of the things we have prepared the database for the ex vivo things actually, because instead of discarding some samples, so from the hospital we bought some of the tissues, and we have been characterized their dietary constant. Based on all these things, we have come up with this sensor, but still it is not 100% accurate. So that's why we will have a surface wave that reaches for the receiver. So to avoid that, like we are preparing this wall. Okay. Hope
Yes,
you
sir.
got
Or
some.
is there
Yes, sir.
any impact of tissue conductivity? And
Tissue
for
conductivity. Uh, See what happens with the tissue conductivity. See, uh, if by our research says actually when we are looking with since microwave and
hmm,
with respect to microwave, the mode of transmission, like say in a waveguide is different, and in this one is different. We call this as like a parallel plate kind of a waveguide. But when you are looking with lossless, dielectric losses is too high with respect to skin. Skin and muscle both are having a dielectric losses more, but whereas fat is less. So while designing a sensor, we look for some booster angle for the penetration. So booster angles. So to achieve, we minimize the surface wave. So tissue conductivity is not possible according to me, because like we are working with something like 2.45 gigahertz. Like it's either it should propagate either in terms of an waveguide kind of a mode, or else with simple like a substrate kind of a mode. So if it is more the conductivity and less the propagation actually. So we never expect that. So
yes,
uh,
yes, sir. And
I yes, yes, please.
is there any optimal frequency range in case of fat-based IBC?
Yes, yes, yes. Fat IBC. Currently, the thing is like when you come up with the publications, or when you are want to come up with any product, it's easy to launch when you are working with ISM, like International Medical Band. So that is like 2.45 gigahertz and 5.8 gigahertz. These two are regularly used frequency. Obviously, in this frequency, it works very well. No worry. And general concept, if you are increasing the frequency, scattering will be more. Say about for millimeter wave communication, we go for communication if you want to have a space communication, other things. So you can go for like millimeter wave, no problem. So and directivity, everything will be super good. But here we are not looking for the directivity. We are not talking like point-to-point communication. We are making use of the fat. So it's wherever the fat is there, it should go with that direction. So we restrict for 2.45 gigahertz, and 5.8 also we have tested. So above that we are not okay to test, because like uh, due to lot of scattering, and it's not essential, and complexity also increases. Okay. So since like this region is completely proved for non-ionizing region. So when you are increasing the frequency and other thing, then we need to provide lot of certification and proof that still it is safe enough for the on-body communication and implant communication. For this one, we don't want to prove more. We have got like sufficient documentation is like from the ISM band, like no one questions more. So to what is that? To experiment, you can experiment any frequency. But bandwidth, with this also you can achieve bandwidth. Say about like what we are achieved recently is 92 Mbps. That is far better to transmit even an 4 to 5 video live channel. So it's bigger, and that application which we are targeting, say from the motor cortex, from the brain signal, EEG signal, to make the hand prosthetic. So we require up to almost 68 Mbps more, because like this many lines to be made. So with the multiplex, and we do have one more technique called backscatter technology. So with that, so currently what is available, the bandwidth with this technology is sufficient. If we require more bandwidth, then we can think of how to increase those things.
And what technique we can use to increase the signal to noise ratio and bit error rate?
Yes, 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 yes. So I can go to the bit rate.
Because
So
these are,
actually, yes,
yeah,
yes, I will come
yes,
to
yes,
this one. Say about this experiment.
yes, yes, yes.
You can follow more in the article. What happened in this one? There's a normalized signal to noise ratio. So
Mhm.
what in this experiment we have made, like we have been defined certain things, and we have increased the noise level and signal level and varied, and we have checked. Okay. So if you want to have, let's say about like 10 point, sorry, 10 to the power minus 6, which is ending, that is almost 99.99. It's super good communication. Say about like, so, and like if you are looking with the current existing thing, obviously some bit rate or this thing and all. So even like 10 to the power of minus 4 or minus 5 is far better. So still, if I want to make any debate, I will make all three are working equally good up to 512 QAM. I can make a debate. But when you're looking with the current application, so current application say about like latest technology with latest 6G or like next coming with 7G, even that will use lesser like 3 by 4 or 5 by 6 uh, what do you say, coding scheme of 64-bit QAM. Current technology has not been used even 128-bit QAM. You are getting my point. So
Yes,
available technology which are having like is still it is not reached for the experimentation purpose. So we will make it, because like being a researcher, we will explore more, because like what is our intention is like what happens for future. So and also this article or this work should be valid for next couple of like decades. That's our intention. So, and also it's a very rarely researched object actually. If you are looking, say about like very few people will work on this. Say about many people want to work on in intra-body communication in future. So at least this work should be reasonably good for like next 20 or 30 years. That is the intention. That's why we have tested over there.
yes, sir, definitely. And what are
And
now?
also, I will add one more point. This is with existing our probes. Say about like one of the implant probes and also on-body antenna. Every time there is a scope of improvement. So this on-body antenna need to be optimized. Say about this is almost 2 3 years old, and always we are preparing a lot of databases. So better and better antennas, better and better probes. That will obviously reduce our bit rate and other things. So obviously there is a scope of improvement. Yes, yes, you were talking about something. Yes.
Yes, sir,
Hello.
yes, sir.
Hmm.
Sir,
Yes, you was asking.
in the same area, what are the future research direction and potential breakthrough
Hmm.
in the fat-based IBC?
Yes, yes, fat ABCs. Yes. Not only with the fat ABCs, the technology, it has been like from like it has been pioneered from our laboratory. So future, what happens is like say about in our things, say about like many people say, even though our group is called microwave medicine, but hardly like one guy of sensor and I'm also microwave guy, and hardly 3 4 microwave guys are working, and rest are with a different background. Say about we do have some computer science background, mechanical background, biomechatronics, phantom based, chemical engineers, and management guys. So the thing is like this is always interdisciplinary. Future goes with a different way. Say about recently, I started my research. Say about like if I'm just 1 second. recent my articles like is like more with machine learning and other analysis actually. So and also WPT power transfer, wireless power transfer system and data characterization. So when I want to say about future, yes, it is there with a different angle. So currently, how we are categorizing the problem and how we are looking at the problem. In future, say about like we require computational people, we require everyone actually. So there is a scope in future, like say about you are a very good electromagnetic guy and you want to improve the sensor thing, you can improve. Or else existing database which we are leaving, that if someone are good at machine learning, they can work on it, and artificial intelligence, they can work on it. So there is different skills are required. Based on that, the future stands actually. The technology remains same. Say about not only our technology, galvanic coupling and capacity coupling. Still, people do that. There's still people, electrical people do that, and they make it without like they are optimizing and they are working on it. So for any technology, there will be certainly a future, and how you are going to work on it. And also, if you are looking with AI and machine learning, only for the signal processing and something a database, say about like if you have too many databases with a lot of measurement to find or train the models, that is useful. Apart from that, the manual work has to be done. Say about like a sensor design, optimizing, AI can just suggest few things, but like you have to do on your own. So, and also phantom design, say about the preparing, mimicking the human tissue. As by the way, phantom, I did not explain what is that. Phantoms means like instead of sacrificing the animal more and less complex experiment on the human, so we will mimic the tissue, say about skin, fat, muscle, all those things, and we prepare artificially inside our clean rooms, our laboratories. So that will have very good similar electrical characteristics of a human tissues. So that we are good at making, and that can work for ultra wide band for us, like very, very big band actually. So we will be testing from the 500 megahertz to 50 gigahertz in our laboratory. It's work very good, and that is also a challenging. Like that means like those who want to make something um, better and better phantom models that is there. If you are a software engineers, you can look at it and make a greater software models and also applications. So desktop applications and other things. If you're a software guy, if you're a mechanical guy, you can design a better what is that geometry for preparing this kind of an experimental setup. And if you're embedded system guy, you can prepare the embedded system for signal transmission and calculating the latency, data rate, bandwidth, uh, errors, and many other channel characteristics. So there is a larger scope of many engineering work. So if you are a microwave guy, obviously this is the basic things you can do that. So these are some of the future aspects you can think about.
And one more question.
Yeah.
So, can we use the fat-based ISC
Mm.
to optimize the power consumption and extend the battery life in wearable devices?
Yes, obviously. See, our idea is to like fat ABC is one thing. Like it will be most of the time we are planning for on-body application, like variable application, not like an implant. Implant is for only experimentation. Like it's not possible for clinical trial or like clinical validation. It's not possible. But on monkeys we did it. Okay. On like porcine experiment, like on pig we did it actually. So last year we did it on the pig. For the battery life and other things, what we are thinking is like there is our another project we call it zero battery. Zero battery, what is it like? Sensors we will call. So for that, it will have some nano generators are there that will directly get some energy and it will work. And also frequency of operation we look for it. Sensors like few sensors like how often you want to look for the measure data and other things. So if it is completely implant, it has to do certain like work and all. For that, through the WPT, we will charge it. Okay, that is one thing. And another thing is like very low profile sensor, and we minimize the electronics. So when we are designing some ergonomous design, say about like for experimentation, we start with some embedded things, means we start with Raspberry Pi and simple thing. So when we are looking with, we have got from the Italian collaborators here, you might have heard like STM, the company,
Yes, yes.
and also like in one project with Bk, we do have collaboration with Intel. So what for the low battery with it, they have got a fantastic device already existing, like sensor type. So that's very low battery and standard on devices. You can see the size of sensor is very small. So we do what is that? Come up with our customized antenna with the Molex connector, and we used to place and we used to experiment it. So those kind of variables, very low battery. And if you are looking with some of the simple batteries, like not like rechargeable, simple battery like 20332, that's very small battery that runs for more than 6 months. So in some of our implanted sports application. So as thing is more than a microwave magic. It is like more than like embedded guys work there. So we do work on that. And also we will confine the radiation pattern as per the microwave guy. We will confine the radiation patterns to reach the fat for fat ABC, like to reach the fat properly. So there we can save some energy. So these are the things we look for, like a low power consumption. And also like some of the simple like uh, now like super capacitors are available for very fast charging whenever you go for like some renewable resource, say about solar, and say about like recently we started with some nano generation with many things actually, say going towards with some of the dam projects here. So that does not require any battery at all. So based on the temperature variation in the water, it's generating the power required for the sensors. So, and also some of the like passive elements as the sensors, not an active elements. So that also it is there. Some like mineral line, microstrip lines we have drawn on the dam to check the crack or like something displacement between two butters dam. So like that ideas can be also make it like battery free.
Yes, yes,
So
yes.
so without battery it can make it. So there are plenty applications, but like also we do work on some of the robotics, part of the robotics like prostate arm. So we are with many field actually. So uh, so any engineering is people are useful for us, starting from civil, mechanical to electrical, IoT, everybody are useful for us.
Yes, yes, yes. And one more question from my side. How the
Mm.
Indian researcher can collaborate with your university?
Yes, that's a fantastic question. We are always happy, but we do have some collaboration from, you might have known IEST Shirpur, and I do have collaboration from Amrita Main University. And personally, I do have very good, one of the great professor like called Danish group. And we do have some collaboration from Triple IT. And s- collaboration is good. And the thing is, like when you are looking for Indo-European projects, or else like it's just for the knowledge exchange, that collaboration is also possible with anyone. But preferably, like when you are looking with the UGC thing, there are like something as state universities, instead state universities, most of the affiliated colleges goes for that. So those colleges has got very difficult for the collaboration with respect to project, because even though it's the private universities or as deemed universities, so which are independent body, will have a direct, they can apply for the direct or like Indo-Swedish collaboration, or like many other Indo-European projects. So the collaborations happens like frequently. There are many collaborations. Unfortunately, we do collaborate. These are some of the successful collaboration we are running with the project. There is one project called Spark that is there. That is majorly used that call, and another one Indo collaboration. There are few. Okay, we are making those collaborations. Eurostars that is there, but most of the time it will be through the uh, like deemed university level, not with affiliated colleges.
Okay.
Uh,
University
so
to university collaboration, it is possible.
yes, possible. Affiliated college, at least they should have a close relationship with any laboratory. Say about in, we do have a good collaboration with Samir from inside there is a IIT Mumbai campus. So they are very good with the microwave. So some of the group collaboration is possible. And well, what kind of a collaboration is needed? That is also there. Whether you want to collaborate through the project or as just a scientific collaboration. And for any of the like research that demands some money, so you require funding for it. Starting hiring some of the PS student or building up the laboratory and bringing up certain equipments. So, what you have seen some of the experiments and all that is like we have been spent a lot actually, but of course it is not from our pocket, it's from the funding and also university funding. So we are fortunate enough, we have got sufficient funding to buy many things. So some of the things has to be repeated or certain things need to be made in India. So there at least that should be there to drive the people. So in that way, like this is a possible thing. Or else like a simple solutions, like if you don't want the funding just with some scientific collaborations means what we can do is that if you are come up with our similar area of interest, if you are come up with certain greater sensor or some maintenance and all, we can help you in testing certain things. Say about the phantoms testing and clinical validation and other things. And if it is difficult to do in India, so that if you send it to the post, then if you're writing the uh, article and all, you can write our article and we can acknowledge us as an author. That is always possible. So based on the contribution, if your contributions are significant, you can allow us to be an author. So those kind of a things can be made. And like preferably if you have any other PhD student with this kind of a thing, we can have some NDA signed and you can have some scientific, what is that, work with us. But project, I think affiliated colleges, I think it cannot be happened.
Yes, yes,
So
yes.
either it
Very,
should be, yes, sir. It's not possible. It's
yes,
not
yes,
possible.
yes. It's very informative information to
Hmm.
all of our FDP participant.
Hmm.
If participant has to ask some questions, ask.
You can ask some generalized question. It may not be
Yes, yes, yes.
exactly if something in this one, like collaboration, that's a interesting question. Like, and also I want to tell a few things like those who are like your students or the thing and all. If you are looking with something Europe option, you can think of Sweden, and also some like it's cold country, of course. But like education's too good, and many people students they get a job immediately, and they are paid very well. And if they are coming as an PhD student, it's more of like a job. They pay very good, almost like Indian rupees. It's like quite a big amount per month. Like it will be 2.5 lakh per month rupees. So it's comfortably good. Even if he or she got married, they can lead their family here. That much they can get as a salary for PhD. So it's quite difficult to get, but like if they're continuously, and if the one way is to enter for this kind of nation is the masters, and if someone has done his PhD and want to approach as a postdoctoral and other things and all, that is also possible. And there is a one more like Europe, there is a most prestigious fellowship called Marie Curie Fellowship that is more successful. People do come here. So I am a permanent employee in the university, but many people from India they come for like 1 or 2 years for the postdoctor. That also is very good. Like and then like if they are not liking, they can go back. Or it says if they did not able to get some better position, continuous position here, so they can still go back to India and they can do their research in extensive way. So these are many options are there. And for your students, those who are looking for um, some master program, MS and all, like Sweden is one of the good. Germany, Ireland, and of course they need to spend some more money, but like they can keep Sweden is also one of the option. Lot many students come, but they come for something a different program, which are more with management and other things. I don't know what makes them to come here for a management program after studying some engineering degree there. So if that is the case, if yeah, you can share my contact with them. I can tell based on that you can choose this kind of a master's program, so you can have better like that is also good
Yes,
for
sir.
the
Yes, sir.
students. For the students, I
Thank you
can give
for.
recommend. I
Yes, sir.
okay.
Yes, sir.
I can give recommendation for the students those who are coming here straight away.
Yes, yes, yes. Thank you very much for sharing the opportunities to all our participants. Participant can take the leverage of these
Hmm.
opportunities to
Hmm.
work in the Sweden.
And also a last question, like if something, if you required any reviews for your PhD students and other things, or if I were to be an because from I am being like successfully reviewing the PhD thesis from few universities, say Mumbai University and VTU and some other universities from Tamil Nadu. You can use my name for the examiner panel for the PhD
Yes, sir.
thesis
Yes, sir.
review. And
Definitely.
before that also, if you want some reviews on that, based on my availability, I can make it. Okay.
Yes, sir. Yes, sir. From participant side, any question? I think there are no questions. So the last it is vote of thanks.
Mm.
So thank you, sir. We would
Mm.
like to extend our heartfelt gratitude for sharing your expertise on intra-body communication during our faculty development program on next generation
Mm.
communication. Your insightful presentation and engaging discussions have significantly enhanced our understanding of this emerging field. Your passion for this subject and willingness to share your knowledge with us are truly commendable. We appreciate the efforts you put into preparing and delivering your talk and being valuable, uh, given your answers to our questions and provide the valuable feedback as well as uh, giving some informative opportunities how we can make the collaboration, how we can do our PhD or postdoc programs in your university. So thank you for this. And once again, I am thank you for your contribution to making this FDP a grand success. We look forward to future collaboration and learning opportunity from your side.
No, thank you. Thank you.
Thank you, Sir Sangha.
Thank you. Bye
Uh,
bye.
for our participants, tomorrow we have two important sessions, communication in healthcare sectors and AI and robotics. So that's all from today's session. Thank you, sir, and thank
Thank you.
you to all the participants.